Hey guys, this is Mrs. Ross. I am recording this video for you today so that we can go over the last parts of 1.3 in geometry. We spent a lot of time on Monday talking about the midpoint formula and what that means, and we talked a little bit about the distance formula, but I wanted to go over that again and then give you an example of how to use the distance formula. So the distance formula is a formula that can be used to find the distance between any 2 points that's on a coordinate plane. So coordinate plane means we have our x and y plane. You can see this box here shows you 2 points. We have A down here and we've got B up here. And A is at x sub 1, y sub 1. B is at x sub 2, y sub 2. That's just their coordinates. It just stands for generic where they're at on the coordinate plane. And based off of that, we can actually find the distance between A and B using the distance formula, and this holds true for any 2 points on a line. Okay, so the distance formula is defined as, first we find the difference between the x's, so we want to know x sub 2 minus x sub 1. That's going to tell us how far apart the x part of the coordinate plane is. And we also find the distance between the y's, so x or y sub 2 minus y sub 1. Okay. And then once we find those differences, what we're going to do is we're going to square the difference, add it together, and then take the square root. Now you might be thinking, why do I have to do all these things to find the distance? Well, this is actually all rooted in the Pythagorean theorem. So if you remember, c squared equals a squared plus b squared. This is using those principles of the hypotenuse equals the squares of the sides to calculate the distance formula. So if you're interested in that, we can find some other videos so you can watch for that. But this is the basic distance formula, and it uses the difference of the x's and the y's to help us figure out how far apart 2 points are. Okay, so we're going to go ahead and we're going to do example number 3. And this is a triangle. So there's 3 points, A, B, and C. And the directions say to find the lengths of the segments and tell whether any of the segments have the same length. So if we're talking about length, that's the same as distance. So we need to find the distance between A and B, the difference between B and C, and the difference between A and C. Now the distance shouldn't matter. For example, the distance from A to B is the same as the distance from B to A. So it could go either way on that. So what we're going to do is we're going to use the distance formula. We're actually going to get to use it 3 different times. So we'll get lots and lots of practice on that. Let me switch colors here. So first off, let's find the difference between, let's do A to B. That's the line right here, right? So for me, I like to label my points because that just helps me out. So I'm going to make A those points x1 and x2, and I'm going to make B those points x sub 2 and y sub 2 because that just helps me out. If that doesn't help you out, you don't have to do it. So the distance between A and B is the difference of the x's, so 3 minus a negative 2, and that's squared, plus my difference of my y's, which is 1 minus 4, which is squared, and then I take the square root of the whole thing. So when I evaluate this, 3 minus a negative 2 is 5, so it's 5 squared, plus 1 minus 4 is negative 3, negative 3 squared. And when I plug this in my calculator, I get about, I think it's 5.83, something like that. Okay, so that's A and B. I figured out the distance of those two. So next up, let's do, so I know this distance, I know the red distance. Now I need to see if any of the other distances are the same. So let's do the difference between A and C. So now, I'm trying to find AC. Now I can keep my A point as x sub 1, y sub 2, y sub 1, that should be a 1 right there. And I'll make my C x sub 2, y sub 2. Okay, so again, it's the difference in my x's. So it's 0 minus a negative 2 squared. And then the difference in my y's, which is negative 4 minus 4 squared. And then I take the square root of the whole thing. Sorry, that's a little bit messy. And one thing to note is it doesn't matter which one you make your x1, y1, x2, y2, because what happens is when you are finding the difference between the two, obviously one will be positive and one will be negative if you're dealing with negative numbers, but when you square it, that kind of takes away. So it doesn't matter which one you pick as x sub 1 and x sub 2, it should work out either way. Okay, so let's go ahead and evaluate AC. So I have 0 minus a negative 2, so that's 2 squared. And then I have negative 4 minus 4, so that's negative 8 squared. Okay, and when I evaluate all of that, give me just a second, I get I didn't write that there. I get approximately 8.24. So it looks like AB and AC definitely do not have the same length. So let's check out B and C and see if maybe that one has the same length as something. Okay. So now we're going to do green. We've got B and C. C is already labeled as x sub 2, y sub 2. So I'll just make B my x1, y1. Again, it's not picky about, the formula isn't picky about which points you use first or second. So we are trying to find, undo that, we are trying to find the distance between B and C. So that's going to be the difference of my x's, which is 0 minus 3, and that's squared, added to the difference in my y's, which is going to be negative 4 minus 1. And that's squared. Sorry, I'm using green on the same ones there. Okay, so if I evaluate that, 0 minus negative 3 is negative 3 squared. Negative 4 minus 1 is negative 5 squared. And when I evaluate that, oops, I get approximately 5.83. So how about that? It looks like AB, line segment AB, and BC have the same length. So kind of bringing that all back together, we could also say that AB is congruent with BC. All right, so that is using the distance formula. You guys should be ready to do all of your 1.3 homework. Thanks for listening. Hope you have a good day. Bye.